Alright guys, so today we're doing the second day of the absolute value notes. Alright, I got the second page here. We already filled out the first page. It looked like this. We're moving on now. Alright, so we just learned about how to shift our parent function left to right, up and down, and we learned how to flip it over upside down. Okay? So from that we can tell that this h and this k are going to mean something involving our vertex. Okay, so initially our vertex is at 0, 0, but remember h moves left and right. Okay, so if h is pushing us left and right, that's going to give us our x coordinate of vertex. Okay, and then k is going to give us our y coordinate of vertex. Okay, x and y, that's going to help us out. And then our a is something we're going to get to. We already know if it's negative we flip it over, but we have a little more to learn about this on the back. So let's go ahead and finish this stuff up first and we'll move on. Okay, so g of x equals the absolute value of x plus 4. What we want to do is graph f of x and g of x. Alright, so we're going to see how this transforms. So let's graph f of x first. F of x is always going to look like this because it's our parent function. So for all of these, we can just draw that in. Okay? Alright, now, we just learned about our x and y coordinates of the vertex. Okay? So we don't change our x coordinate. It's still going to be 0, but our y coordinate is going to be positive 4. We know we're moving up 4. Okay, so let's go ahead and toss that on 4, and everything is shifting up 4. So we can fill in our graph just like this. Obviously it goes on above that. We can draw little arrows to show that. But that's all we did. All we did was move up 4. Okay, so moving down, we're still opening up. Horizontal shift, none, because we didn't have an h. Alright, vertical shift, plus 4. Or up 4, however you want to say it. Okay, vertex, we already kind of talked about this, but we have our h was 0 and our k was positive 4. So we're going to be 0, positive 4. Axis of symmetry, that's whatever splits our graph in half, so that's just going to be the y-axis. That's when x is 0. Domain stays the same. All real numbers. Range is actually going to change a little bit. We are everything greater than or equal to 4. So 4 and above. Alright, moving on. Let's cruise through these next couple. Alright, now x minus h. Minus h gives us the value of our x coordinate. Okay, so minus 2 means our x coordinate is positive 2. Okay, so 2. And then our k is negative 3. Alright, so we're going to move right 2 and down 3. So 1, 2, 1, 2, 3. We're right here, and that's all that changed. So let's go ahead and fill in the rest here. Alright, that's what our graph looks like now. Kind of sloppy, but that's the gist of it. We're still opening up. Horizontal shift, we are moving right 2. Vertical shift, we went down 3, which means our vertex is going to be 2, negative 3. Okay, axis of symmetry, that changed now. We can look at our x coordinate. The x coordinate is where it's going to split in half. So whatever the x coordinate of our vertex is, that's going to be our axis of symmetry. X equals 2. We have to have the x equals because our axis is a line. Domain, all real numbers. Range, we moved our graph down 3, so y is greater than or equal to negative 3. Alright, moving on. So we have a flip here. Remember, that's what that means. Alright, and then x plus 1, that means our x value is going to be negative 1. Okay, because we want x minus h. Let me slide this down. X minus h. Okay, so x plus 1 means it's going to be negative 1. And then positive 5 for our y. Alright, so let's go ahead and graph this first. We're going to move left 1 and up 5. 1, 2, 3, 4, 5. So that's our new vertex, but remember we got to flip it as well. So let's go ahead and draw our lines. A little sloppy, but that's alright. That's our new graph. So now we're opening down. Our horizontal shift is actually left 1. Vertical shift up 5. Vertex -1, 5. Now we're up there, remember. Axis of symmetry, we take our x value again. So x is -1. Domain, all real numbers. Range is a little different. We're actually less than or equal to 5. Alright, sorry, let me slide out. Less than or equal to 5. Okay, we can move on to the back side now. Alright, we got to talk about A. We're not going to fill in this first sentence yet. Let's see what changes about our graphs before we fill that in. Okay, so A times f of x. Alright, so f of x was this normal function. Okay, our parent function. We've seen that a million times. Now we're multiplying it by 3. Okay, so when x was 0, y was 0. Okay, 0 times 3 is going to stay right here. That's not going to change at all. But our next point that was here, we got to multiply this by 3. So 1 times 3 is actually going to be way up here. Next thing times 3 is going to be way up there. Okay, so we need to make sure that we are getting these points right. Our graph looks a lot different now. Okay, this is a whole new change that we haven't seen yet. This is a vertical stretch. Okay, that means our graph is getting a little skinnier. Okay, so 3 was our coefficient. Let's go ahead and fill in this sentence here. It'll kind of explain what's going on. If A is blank, the absolute value, and is a number blank, then the transformation is A blank. Alright, so if A is outside the absolute value, okay, so we would have this as 3 times x, so outside of it. Okay, if A is outside the absolute value, yikes, my bad, and is a number greater than 1. Okay, that's the important part. So since A is greater than 1, our graph is increasing at every point. It's getting way bigger than it typically does, and that's why it looks skinnier. Okay, so as A becomes bigger, the graph becomes skinnier or thinner, depending on how you want to say that. Some people say different things. Alright, we'll move down here. Now we have -3, so as you might have guessed, it's going to be the same as up here. The only difference is that we're going to be flipped over. Okay, so this +3 is going to go down to -3, and then -6. That's what our graph looks like. Okay, so same things, just flipped over. Alright, top right now. Now we have 1/3. Okay, so instead of tripling what's going on, we're actually going to have 1/3 of it. So we're actually only going to go up to right here. Our first time we hit 1 is going to be at 3. 1/3 times x. Okay, so when we plug in 3 into here, we get the absolute value of 3, which is +3. 3 times 1/3 is going to give us 1. So 3, 1. So we can go to -3, have the same thing. 6. 6. Alright, graph looks way different again. Okay, so now we have that A is still outside the absolute value. But now our number is less than 1 and greater than 0, which just means it's a fraction. It's going to be some small number between 0 and 1. Okay. Alright, so our transformation is a vertical compression here. Remember, our first one was vertical stretch. If you want, you can write those in. I won't make you. Vertical compression and vertical stretch. Sorry about that mistake. Okay, vertical stretch, vertical compression. All right, let's look at our last one. As you might guess, it's the same thing but flipped over. It's going to look just like that. We can fill in our last thing. As A becomes smaller, the graph becomes wider. All right, that is it. We have finished all of this. Let's go ahead and go back to A, and that's going to tell us our flip and stretch. So it's going to tell us whether it's upside down, like flipped over the x-axis, and whether it's stretched this way or this way. All right, that is it, guys. That's all we have to know about absolute value. So congrats. Good stuff on the notes. No notes tomorrow.